data sets aren't all that clean, but it requires stepping out of your comfort zone and actually starting to think about it like, okay, how do I get approximates? How do I think about data differently and not needing the structure that we are expecting? And this is another quote that I really like. It's not the quantity, because I was always mesmerized when people said big data, big data, big data. It's never been the quantity. We've always had technology that allows us to at least sample our data sets. And within statistics, sampling isn't necessarily a bad thing. It's nice to use a lot of data, but at the end of the day, we manage to drive real business insight using samples of data. So it's not the quantity of the data that's revolutionary. It's that you can actually do something with it. They've built technologies now that allow you to build models on top of that. And that's one more reason why your data scientist is sort of a specialized subset where you're actually able to leverage those tools. And the final thing, it's a really cheesy Einstein quote. I mean, you kind of expect them in all the tech presentations, but I really like this one because it articulates why that cross-functionality within data science is really important. You can't solve the problems with the exact same thought process every single time. You need to have the outside perspective looking in. So this should start painting a picture for what is expected within organizations of their data scientists. And typically when I do this presentation, we're talking to some of the senior leadership, and they're actually right at the fledgling stages. They have a BI practice, they have an early analytics practice, but they're thinking, okay, what is it going to take? Everybody's doing data science. Where's my competitive advantage? This is what we have to start talking about, because they're wondering, who are we hiring? What type of person am I looking for? What are we trying to get at? So let's start defining the data scientists themselves. This is a mashup of a couple definitions I liked, but the things that I really take away from this: effectively communicates generalizable insights. That's one of the big core features of your data scientist. Not only are you supposed to be able to apply your statistical knowledge or your machine learning knowledge or even basic stats approaches to the data set, you have to be able to talk, and you have to be able to sell that within your organization or to your client. So in my case, I deal with a lot of clients. I'm not part of their organization. I handle the relationship head on. But if you are within an organization with a data scientist, they are expected to bridge the gaps in between business units and the stats folks who are very good at building the models but have a little difficulty communicating. And so a good data scientist sits right there in the middle and makes it seem like the stats are simple. It's kind of a thankless job, because at the end of the day, you don't see the 200 hours of work that went into your model. You just show the 2 or 3 data points, those 2 or 3 results. But that is the job of your data scientist. So when you think about why we're all cranky all the time, it's usually because of this, because you don't recognize the level of work that goes behind it. But that's fine. That's the whole point. You're supposed to be transparent and make the data just hand over the results. So that's really important. That communication skill set is critical for your data scientists. And they should be able to do this regardless of the software, hardware, and bandwidth constraints. And that goes to my 2 warnings that I'm going to come up next with the term data scientist. That last part there is really critical within your organization. You should never be forestalled or stalled by your lack of software, lack of hardware, or how much time you have. There are always smart ways of doing something. The whole reason why, oh gosh, who is it? It's another Harvard, or no, actually it was a foreign policy article about data science and just the job structure. One of the things they said was, why are these people getting paid so much if they're not managing a team? And it's technically they're managing a team, it's just a lot of little robots. So within data science, you have to figure out, how do I be efficient with my bandwidth, right? Because there are so many questions you can assist in the organization. And when we get to the framework part of this, I'll talk a little bit about prioritizing those requests and what that looks like from can we actually support this type of analysis? Can we actually find real actionable insights that will give you value? So, warning number 1 I have as we start talking is not all data scientists are actually data scientists. And not all non-data science roles or actually some non-data science roles are actually data scientists. So this is a bit of a logical trip. The first part is, not all data scientists are actually data scientists. It's important to remember data science is not reporting. Within organizations, you'll have a lot of people who come in as data scientists, but they get frustrated. And the question you have to ask is why? It's because they're put into reporting roles, they're put into basic analysis roles, but the skill set I just described requires a different internal structure to handle, right? You need a different type of management for that team. It's not about taking requests from the business, it's about having a conversation back with the business and saying, this is feasible, this is not, and we think you can continue to develop your competitive advantage by doing X, Y, Z. So those are the type of recommendations. So you'll have a lot of folks who will gravitate to the title, but don't do any of that type of work. And that's really critical, because those are the organizations who actually successfully use data science within them. That's important. The second thing is, not all non-data science roles are actually data science. So there are non-data science roles where the person is doing what I would refer to as data science work. And a good way of thinking about that is, I used to work for an ad agency, and we had a strategy analyst who would pull down 10 to 20 tweets of the top customers that he was expected to analyze. He would parse them and score them in Excel, just using like the regex commands within Excel, just equals split string and do all this. And he would analyze them and score them. That's actually pretty data science-y. From a conceptual standpoint, you have to go above and beyond to actually get that type of information. And his insights were always spot on. So that should tell you something about the tool requirements. It's not always going to be you have to code. You always need to write code for this role. It's how do you think about it. The coding is secondary. You'll pick up the language as you need it, but at the end of the day, it's do you think like that? Can you think laterally about the problem at hand and use the tool sets that you're given or the skill set you have right now? Also, the other thing is, not all data science is big data. So I'd say about half the clients we run into start off by telling us, well, we don't need